Okay, so today we'll start understanding relations and functions. Okay. Now, I think the relations and functions are dealt in two chapters, I guess, in CBSE. I think there is one chapter in 11th standard. There's also another chapter in 12th standard. Okay. Maybe the chapter in 12th standard will be slightly difficult compared to the chapter in the 11th standard. I think you understand the reason, right? Obviously. So to really understand relations and functions, there are prerequisites also. Okay, so you need to be good with your basic algebra. Okay, so you need to understand how to solve quadratic. Okay, sometimes the process when it comes right now, it's very difficult to understand. Okay, when I say that a particular problem can involve any topic, but this is one particular topic, that's true. Okay, the problem can actually involve any of the areas that you study in maths. Okay, but again, so don't worry what a relation is, don't worry what a function is, we will understand today. Okay, maybe we will only try to discuss relations today. In the next class, we will talk about functions. Okay, so now let's look at this scenario. Suppose you have, let's say, a set of pants. There are two pants. Let's say we're just calling them P1 and P2. Okay, so it could be like, I don't know, maybe a black jeans and a blue jeans, whatever you want to imagine, you can imagine. Okay, and there is a set of 3 shirts. Now, if a man wears a pant first and then wears a shirt, in how many ways can he dress himself? Okay, very simple scenario. Would you like to answer this? Okay.
There are 6 possible ways.
Very good. There are 6 possible ways, right? So one of the pants can be chosen first, and then whatever pant he selects and then wears, he has 3 choices, right? So now here, there is a reason this has importance, right? He's choosing pant first. Okay, he's wearing pant first. So that's like it is happening first, and then wearing a second order. There is an importance to the order here. Okay, 6 ways. Okay, so you can take P1 S1, okay, P1 S2 or P1 S3, and then he can take let's say P2 S1, okay, or P2 S2, and then P2 S3. So these are the 6 different ways in which he can dress himself. Okay, and then here, understand, we are writing the selection that he makes, okay, using, let's say, 2 elements. Okay, they are placed inside this normal parenthesis. Okay, so you have P1 as the first element and then S1 as the second element. And then in the first element, you will get only pants. In the second element, you will get only shirts. Okay, so such, these are pairs, right? You have pairs. The pairs where order is important, such pairs are called ordered pairs. Okay, so here, if you select the shirt first and then select the pant, that's a different pair. Okay, so let us understand that. Now, what is Cartesian product of sets? Okay. Okay, so here we are looking at sets. There are 2 sets that we are taking. Okay, set A and set B. Okay, so this is important. Cartesian product. Okay, so this is a new concept that we are learning. So what is the Cartesian product? You write it as A into B, but it is read as A cross B. Okay. Now you have to be careful with this symbol. This multiplication can mean different things depending on what you have, let's say, to the left and to the right of that symbol. Okay, so if you have simple numbers, let's say 2 and 3, 2 into 3, you will get 6. Okay, if you have vectors, it could mean a different thing. Okay, so if you have matrices, it could mean different things. Here you have sets. A and B are sets. So this multiplication symbol, you need to treat it as an operator, which is working on these two sets, and it is giving you something. Okay, now what is it giving you? It is giving you set of all ordered pair of elements from A to B. So now if you look at the previous problem, where we had a set of pants and then a set of shirts, we had ordered pairs. Okay, so pant first and then shirt next. So we had all those 6 ordered pairs. Okay, so we can say that whatever we obtained in the previous example is a Cartesian product of those two sets. Okay, are we okay with this definition of Cartesian product?
Yes, sir.
Okay, Om, fine. Okay, good. Okay, guys, one more thing. Let me just confirm. Are you able to see the screen completely, right? The video is not blocking any content?
Actually,
No, no?
no. Actually,
No.
myself view itself is blocking some of the content. I don't know how to remove it here.
Achha, your self wave is blocking.
Yeah, like I have no video on, but still it shows like my own self view.
Achha, do one thing. I think if you, let's say if you right click on view, na, there is, if you're at the right corner, there is a view na, with 3 dots on a box.
Okay. No,
View,
sir,
view. Right top corner, there is a hide self view. Do you see that? Hide self view. Achha, the top right corner, when you click on that view, I think there is a hide self view. Maybe if you click on that and then see.
No,
it
sir.
should
No
close.
change.
Yeah?
No change, sir.
No change? Did you click on that?
Actually, I have no such option, sir. I'm on tab.
Achha, okay, I think, yeah. I think Windows version and then tab versions are slightly different, I guess. So what shall we do then?
Sir, I'm just dragging it, so I manage it, sir.
So you manage it, right? Okay, take it. Om, you don't have any such issues, right? Okay, take it. So we'll forward. We'll move forward. Okay. Okay. Now make sure you understand what this Cartesian product is. Okay. Again, you need to understand Cartesian product is also a set. Okay. When you have this cross symbol, multiplication symbol, when it acts on set A and set B, it is giving you a different set, but the elements in the set are ordered pairs. Okay, so the first element in each pair will belong to set A. The second element will belong to set B. Okay, so we are getting such a set. That set is known as Cartesian product. Clear? Okay.
Yes.
So let's take an example. Okay, I think before the set notation is this. So if you take A cross B, we are getting, how do you read this set builder form? It is set of all ordered pairs A comma B, where A belongs to set A, that which is the first set, and then B belongs to set B. Okay, so this is how it's written in set builder form. Okay. Another thing here, if either A or B is a null set, okay, if A or B, if there are no elements, you cannot really pair up elements, right? One of the sets has no element. So in that case, your Cartesian product will also be a null set. I think this is understandable. Yeah,
Yes.
Harsha, are you okay?
Yes. Yeah.
Okay. Now, example of a Cartesian product. Okay. Now let's look at this. There is an academy, and this academy has 2 sections. Okay, it's a very small academy. Okay, and then each section has 5 students. Then, if you are trying to get roll numbers for these students, let's say, okay, now how can the roll numbers be? One such way is you're getting like each roll number. I can treat it as a pair, right? Okay, which will identify the section and maybe a number that you associate with the student. Let's say, for example, if you say A1, like section 1, and then whoever joined first, maybe he's given that roll number 1. Okay, so A1. And then similarly, you have these ordered pairs. Okay, I'm not putting a bracket around them. And I'm also not separating A and 3, but you can treat this as an ordered pair. Okay. So B1, B2, B3, and then B4 and B5. You guys understand this? This is an example of Cartesian product.
So one of the sets have their values as A and B, and the other set has values from 1 to 5.
Exactly. Okay, so that's very good. Okay, so the first set has like A and B. The second set has 1, 2, 3, 4, and 5, and then you are getting the ordered pair of these 2 sets. Yes, exactly. Okay, now few simple ideas here. 2 ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are equal. Okay, so the Cartesian product has ordered pairs. So if you take 2 ordered pairs from a Cartesian product, if they are equal, let's say, you can say that the first elements must be equal and the second elements must be equal. Okay. So for example, if A1 comma B1 is equal to A2 comma B2, then we know that A1 is equal to A2 and then B1 is equal to B2. Okay, so a simple example. You have a Cartesian, not a Cartesian product. We have an ordered pair here, x plus 2 comma y minus 2. So this is equal to 5 comma 7. Okay, so you're asked to find the values of x and y. Now, if these 2 ordered pairs are equal, the first elements, the corresponding first elements, x plus 2 and 5 must be equal. Okay, so in this case, x should be 3, right? 5 minus 2. Similarly, the second elements, which are y minus 3 and 7, they must be equal. Then here y should be 10. Okay, so we understand the equality of ordered pairs.
Yes.
Okay. Then, okay, I think this is also should be easy to understand. Okay, so now maybe you can go back to that pants and shirts problem. I think when you said there are actually 6 different ways, the pant shirt, the set of pants, there were 2 elements, right? 2 pants, and this set of shirts, there were 3 elements. Okay, now 2 into 3, 6 different pairs we were able to make, 6 different ordered pairs. So in general, if you're trying to get the Cartesian product of sets A and B, if the number of elements in set A is m, the number of elements in set B is n, the number of elements in the Cartesian product, okay, so the set which is the Cartesian product, will be m into n. Fair enough? Harsha, you're okay? Harsha, are you there? We lost him?
No, sir. I was
Ajay, you are there, okay. Achha. You understand this?
Yes, sir, I do. So what's the like m, sir?
It depends. It depends on the set. This is like you're writing in general.
Okay.
So, I mean, you can recall that pants and shirts example, right?
Okay. So
In pants and shirts example, the set of pants has how many elements? 2 elements.
Yeah, so it's M.
So that is M. Okay, so the set of shirts, which is, let's say, our B set, it has 3 elements. So 2 into 3, there are 6 ordered pairs in the Cartesian product. So there are 6 such elements. Similarly, you can also go back to that academy sections and then 5 students in each section. There again, how many ordered pairs we made? We made 2 into 5. There were 10 ordered pairs. Remember? I hope you understand, Harsha, here.
Yes, sir, I did.
Okay. Now, what do you think here? Okay, so if you have 2 sets, let's say P and Q, is P cross Q, is Q cross P? If you take Cartesian product of P and Q, is it same as taking Cartesian product of Q and P?
No, sir. The order will definitely differ, sir, in both of them.
Exactly. The order will definitely differ. But do you think, is there a possibility that these two may be equal?
Yes, sir. If both of the sets contain same elements and same number of elements also, sir.
Very good, very good. If both the elements have same elements, then obviously your P cross Q should be equal to Q cross P. Fantastic. Yes, very nice. So let's verify this. Okay. So let's say, suppose I'm taking an example. To set P has these elements 2, 4, and 6. And then set Q has 1, 3, and 5. So if you take the Cartesian product, you get these, right? So set P has 3 elements. Set Q has 3 elements. So how many ordered pairs are there here? There are 9 ordered pairs. And then I think it's easy to look at those formations. So 2, 1, 2, 3, 2, 5, and so on. I'm sure you understand this. But now if you, let's say, do Q cross P, the first elements will be from set Q. Okay. Obviously, these two are not equal. Clearly, they are not equal. Right? Do we get this? But as Om pointed out, if the sets are equal, let's say, P and Q, if they are equal, then if you do P cross Q or Q cross P, you will end up having the same Cartesian product. Okay. Harsha, you understand?
Yes, sir.
Okay, very good. Okay, so nice. So now they are equal. Okay. Okay, so if P is not equal to Q, okay, so if they are like not equal sets, unequal sets, then your P cross Q is not equal to Q cross P. So you understand, this is not commutative, okay? The commutative property doesn't hold good here. For numbers, it doesn't matter, right? So 2 into 5 is 5 into 2, but here it doesn't work. Okay, so now in Cartesian product, we are actually operating on 2 sets. Okay, so sometimes there is a need to operate on 3 sets. In fact, you can actually extend this. Okay, you can extend this to any number of sets. But let's say you have a set, and then you are doing, let's say, A cross A cross A. Whether you are operating on the set 3 times, then you get instead of getting an ordered pair, okay, you get something called ordered triplet. Okay, so you have a triplet here, a triple number. So this ABC is called an ordered triplet. Okay. Okay. Now this symbol R is the set of all real numbers. We understand the real number line. Okay, so you have all those rational numbers, irrational numbers. Okay. Now you can, this is a set, right? So if this is a set, I can do R cross R, right? I can do a Cartesian product of R and R. So when you do that, what is that you're going to get? You're going to get all points in the two-dimensional space, right? So let's say, for example, I have a diagram, I think here. Okay, so here if you see the horizontal axis, okay, which we normally call as x-axis, okay, it has all real numbers. And then the vertical line, the y-axis, it also is used to represent all the real numbers, and a combination of these two. When you do a cross, you are taking an element from the horizontal axis, and then you're taking an element from the vertical axis, and then you are getting a point in a plane. Okay, so in two-dimensional space, basically a plane, all points become elements. Okay, so they become the elements of R cross R. You're okay here? Om,
Yes.
Harsha?
Yeah.
Okay, so now here R red. Can we have RRR? The famous RRRR? Can we have triple R now? Look, the ordered triplet. What do you think ordered triplet will be? RRRR. What will that be? Okay, so R cross R cross R. Okay. So this represents coordinates of all points in the three-dimensional space. So you have x-axis, y-axis, z-axis. So if you have ordered triplet, that ordered triplet is basically a point in space. You understand the meaning here? So when you take this set of real numbers, if you take this RRRR, okay, it's an ordered triplet. Now this ordered triplet is basically, okay, you have a set of ordered triplets, and then each ordered triplet is a point in space, okay, 3D space. So you can imagine the 3D space to be like, okay, maybe you have a box here, you have x-axis, y-axis, you can take any point, right? So for example, this point, it will have x coordinate, y coordinate, and z coordinate. Okay, so that's an ordered triplet. Okay, so now here, okay, so I think what I will do is I'll pause here for a minute or so. Would you like to verify if these are equal, given these three sets? Okay, I want you to verify whether these two are correct. Okay, and then we'll discuss after maybe 2 minutes.
Okay.
Okay, so Harsha is saying both are true. Let's verify that, okay? Okay, so given these sets, I think you understand how to get the union of B and C. This is okay. So you have 0, 1, 2, all elements. And you know how to get the intersection of two elements, sorry, not elements, intersection of two sets. Okay. What, Om, you're not sleeping nowadays properly?
No, sir. Today I didn't, like last night I was awake, sir. I was with a friend.
Achha, okay. So now if you have the B union C set, now you understand the Cartesian product of these two. Let's say if you take a look at A and then B union C, is basically the same same set. Okay, so you get this Cartesian product, right? Okay, and then if you take A cross B intersection C, you get this Cartesian product, and then now we can get the Cartesian products and then take their union. Okay, so I think A cross B, we understand. Okay, so 0, 0, and then 0, 1, and then 1, 0, 1, 1, 2, 0, 2, 1. We get this idea, right? And then similarly, we take A cross C. And then you can take the union and then intersection. You can clearly see that the cross symbol nicely gets distributed with the union or the intersection symbol. Basically, you can distribute this like your regular, let's say, distribution properties. So A cross B union C is A cross B union A cross C. Similarly, A cross B intersection C is A cross B intersection A cross C. So very good. Okay, so these are verified. Okay, so I think this should be easy. So if I have an element, this element has, sorry, why am I saying element? If I have a set, okay, this set has only 2 elements. And then we are doing a cross 3 times, okay, A cross A cross A. So we're basically trying to get the ordered triplets here, okay. Now, how do we get these ordered triplets? So these are the ordered triplets, right? Now, how can we get these ordered triplets? Guys, can I think of a different example here? So when you really look at this ordered triplets, can I say that if I have a coin, if I flip a coin, what do I get?
Head or
Get
tail.
either head or a tail, right? Of a coin, I can say that is the set heads or tails. And then if I flip the coin 3 times, I'm doing something like A cross A cross A. And then basically whatever we have listed here is the outcome of all those 3, let's say, tosses, coin tosses. Can we say that? Do you understand the connect? You can say analogy here. So what we can do is, if this is how we can get the triplets, you can actually start with A1 or A2, right? You can start with A1 and A2. And then the first element, or you can say first number, I think you can say first element of each ordered triplet can either be A1 or A2, right? So if you look at the first element of each triplet, it is either A1 and A2. And of course, the same thing is true for the others. But when you start with A1 and A2, I can go from A1 to either A1 or A2, right? And then if I start from A2, I can go to A1 or A2. Okay, so I get the some kind of tree structure which will help me get all these ordered triplets. So then from each of these branches, you can go and get that ordered triplet, right? So here you have, let's say, A1, A1, and then you are getting A1. Okay, so similarly, A1, A1, and then you're getting A2. So similarly, all those ordered triplets can be obtained. You guys understand how did I list those ordered triplets?
Yes, sir.
Okay, very good. Okay, so now here, if you are given, let's say, a Cartesian product, and then you are asked to identify these sets. So then what you do is a simple thing, right? So if you are trying to look at the first set, the first set should be having the corresponding first elements as the sets, right? So that means the first elements, if you look at all the ordered pairs, you have A1 and A2, that's it. So that means your A should be A1 and A2. Similarly, the elements of B will be the second elements of the ordered pairs. So if you look at, you have only B1 and B2, right?
Yes.
Okay. Now, the Cartesian product of A cross A has 9 elements, okay? Among which these are the 2 ordered pairs. Okay, now if you are asked to find A cross A, okay, so you're doing a Cartesian product of A on A itself, okay? So if there are 9 elements, how many elements will be there in A? Okay, the Cartesian product has 9 elements. So how many elements will be there in set A?
3.
3 elements. Okay, now A is also the first set, B is also the, sorry, A is the first set and A is also the second set, right? So if I look at the first elements of the ordered pairs, I have 0 and 1. So I already have 2 elements. Because the second set is also A, I'll look at the second elements, I have 1 and 2. So that means, can I safely say that set A has elements 0, 1 and 2?
Yes.
Yeah? Can I say that? Om, are you okay? Then once you get the set, and then it is easy to get the Cartesian product. Okay, so once you identify the set, you can list down the Cartesian product. We're okay, guys? Okay. Then now we are looking at a relation. So we want to understand what a relation is. So let's take an example. Okay. Okay, so this is a famous thing in Hyderabad. Okay, I don't know whether you know this or not. So if you go to Irani cafe, chai, biscuit, they're related. And then I don't know this combination, if you tried or not. I think if you are having black coffee, dates actually go with that. So we are kind of relating them. Okay, so the way we are relating is like we are saying that, okay, so they are better consumed together. Okay, so maybe or milk with bread or milk chapati. Okay, so now we are trying to find a relation between a set having some elements. So in this case, you have tea, coffee, milk, and then you have another set with these food items, biscuits, dates, bread, and chapati. You are trying to relate them. So that's a relation. I mean, you can have, let's say, 2 sets related in any way you like. Okay, now this is my preference, let's say. Okay, so the relation is my preference. Maybe your preference could be different, right? You may like to, I don't know, maybe tea and then bread may be okay. You guys understand this? Okay, it's up to us. Okay, you can actually relate it in any way you like.
So they're like common, but milk and tea.
What is that?
If there is like common relation between milk and tea.
Milk and cheese.
Tea.
You can say that. I mean, what the idea here is, if you have 2 sets here basically. Okay, you have some set. Let's say I call this as set A, and then you have some set B. You are having some relationship. Okay, now that relationship could be meaningful to a person, may not be meaningful for a different person. So you can define your own relation. So let's say I like to, let's say, eat biscuits while I drink tea, then I have a connection there. Okay, and then I like to eat dates when I drink, let's say, black coffee because I like it. So I have a connection. So I'm saying this way of relating one elements in a set to another elements in a set, I'm calling it as a relation. You understand, Harsha? Harsha, are you there? Okay, we lost him, or is he there?
No,
Yeah, you understand. So it's just relation is just some connection that you make between the elements of the sets. Okay, now one thing, if you go back to Cartesian product was also working on 2 sets, right? See, Cartesian product was also defined on 2 sets. Your relation is also something that is defined on 2 sets. Okay. Now, if you think about the Cartesian product of, let's say, A and B, you are actually connecting all the elements of A to all the elements of B, right? So here, if you think, I'm not connecting tea with, let's say, dates, bread, and chapati. I have not connected them. But if you look at a Cartesian product, you would have connected tea with dates, bread, and chapati also, right? So here I'm connecting coffee with only dates, But if you take a Cartesian product, you have to connect with other elements in set B also. So can I say that a relation is going to give me ordered pairs, but only few of the ordered pairs of the Cartesian product? Can I say that, guys?
Yes.
You guys understand? You understand? Let's say if I'm looking at A cross B, suppose. Okay, so if I write down A cross B is going to relate everything. Let's say here I'm going to use the first letters to identify. So T biscuits, and then T dates, and then T bread, and then T chapati. I'm going to get all the ordered pairs. But when I have a relation, okay, when I have a relation, I am not going to take all the ordered pairs. I'm going to take only those ordered pairs which have meaning to me. Okay, so suppose if Harsha is making a relation, he will take ordered pairs which are meaningful to him. So he can define his own relation. I can define my relation. Om can define your own relation on these two sets. Okay, so the basic idea here is like the beginning idea that you need to understand is you have two sets. Okay, on those two sets, you can have a Cartesian product, right? On the same two sets, you can have a relation. But in the relation, you are getting these ordered pairs, but these ordered pairs are also present in your Cartesian product. So you can say, in a way, it's a subset of the Cartesian product. Can I say that a relation is a subset of the Cartesian product?
Yeah.
Guys, can I say that?
Yes.
A relation is a subset of the Cartesian product. Fair enough?
Yeah.
Yeah. Okay. So that's the definition. Okay. So that is the important definition for a relation. Okay. So what is a relation? A relation from a non-empty set A to a non-empty set B is a subset of the Cartesian product A and B. A cross B ka subset is a relation. You guys understand this?
Yes.
And then maybe in the next class, we will try to put maybe few more meaningful restrictions and then define function. Okay. So we are like going from understanding sets to Cartesian product to relations and then functions. So that is the natural progression that we will see here. Okay. In understanding these things. Okay. Okay, now the relation is based on any connection. Okay, so it doesn't matter. Any connection between the first element and the second element in the ordered pairs of A and B. Okay, so just a subset of A cross B. Okay, if any ordered pair, now these are some definitions that you need to keep in mind. Okay, so you can say terminologies. Okay, so if you have an ordered pair, okay, so if you have an ordered pair here, if you take B, B is called the image of A. Okay, so if you take B, B is the image of A. Do we understand this? A term that you need to understand. Okay, so B is image of A. Okay, so here I have a relation. Okay, and then the set A has these 3 elements, and then set B has these 4 elements. And then here we are connecting only a few of them. Let's say A1 is connected to B1, and then A1 is connected to B2, and then A2 is connected to B3. You can actually leave certain elements without any connection in a relation. Okay, but when you are writing down a Cartesian product, you cannot do that. Okay, you have to have all the ordered pairs. Okay. So again, so here the idea is few elements of A and B may be left out. Okay, maybe I think I should write not let out, maybe left out. Okay, so you can left out, and then few more terms, guys. Few more terms. Okay, we have a domain, range. Okay, now what is the domain? Domain are is the list of elements that you are list of elements from the first set, which you are mapping with the elements of the second set. Okay, in this case, if you see, only A1, A2 are mapped, right? Only A1, A2 are mapped. The set of those mapped elements will form the domain. You understand? Okay, so the domain is the set of elements in the first set which are mapped to the elements in the second set. Okay, in this case, A1 and A2. And then whatever elements that you are mapping into, okay, so here B1, B2, B3, these get mapped, right? So the set of those elements is called range. And then there is another definition, or let's say name, codomain. Codomain is basically the second set. The entire second set is basically the codomain. Okay, so 3 new terms that you must let's say understand and remember. Okay, so domain, range, codomain. Can I say you understand these? Om, Harsha?
Yes.
Fine?
Yes.
Okay.
Yeah.
Now, in the previous example, we said that some of the elements in the second set, set B, can be left out. Okay, but your codomain is the entire set B. Your range is always a subset of your codomain. Okay, so this is, again, you should keep in mind. Your range is always a subset of codomain. It could be equal to codomain. Okay, so still you can call it subset, right? Okay, so now let's take an example here of a relation. Okay, so we have a set A, which is the natural numbers from 1 to 10, and then we are defining a relation from A to A. Okay, so we are defining a relation from A to A. Now, how are we defining that relation? 2x minus y should be 0. Okay, or if you want, you can say, if you rewrite it, you want your y is equal to 2x. So that is a relation. Okay, now x and y, they both belong to A. Okay, so these are the, you're using these numbers in the set A, and then you're forming a relation. Okay, now first think about this. If you're not worried about relation, let's say, if you're not worried about relation, in the Cartesian product of A and A, okay, you can take a Cartesian product of A and A, right? How many elements will be there? A cross A. Guys, if you look at A cross A, how many elements will be there? Think about A has 10 elements. So
100,
Cartesian product
100,
will have very
100.
good 100 elements, right? 100 ordered pairs. But when you define some relation, okay, you are not going to take all those ordered pairs. You're going to pick only those ordered pairs which are going to follow this, right? You understand? So now let's list them down. So your x can be anything from 1 to 10. So suppose if I take x as 1, my y will be 2. If x is 2, my y will be 4. If x is 3, y will be 6. X is 4, y will be 8. X is 5. Now, why am I not taking x as 6? Harsha, why is there no x6 here? Okay, Om, can you tell me why there is no element? Why is there no 6 as the first element? Why is there no ordered pair with 6 as the first element? Okay. Okay, if you take first element as 6, what should be the second element? X comma y, right? First element is 6. What should be the second element?
12.
12. Now, do you have 12 in A?
No, sir. No.
So, because there is no 12 in A, you cannot have this. So, similarly, can I have 7 and 14?
No, sir.
No. So, that means I cannot have any of those numbers after 6, including 6. So that means I'll get only these ordered pairs, right? That's the relation. You guys understand? Okay, Harsha, are you okay?
Okay, I got it.
Om? Fine. Okay, so let's move on. Okay, guys, am I going too fast today, or is the pace okay? Because I think we are trying. I mean, I'm trying to avoid too much of writing. So PPT we are trying to run through it.
Yes, sir, no problem.
I think this is good, right?
Yes, it is.
Yeah. Okay, so now domain. When you look at the domain, you should only look at those elements of the first set which got mapped to elements in the second set. Okay, so likewise your range will have only those elements in set B with a mapping in set A. But if you look at the codomain, you just take the second set. Okay, so here you are doing A onto A, right? So okay, now this is one thing that we need to understand. Now, do you remember power set? Do you guys recall power set?
Power set.
You recall power set? Power set is what? Power set is if you have a set, let's say suppose if you have set A, let's say I have set A with the 2 elements, 1 and then 2. What is the power set of A? Power set of A is subset of, okay, sorry, I think it's not that. It is the set of all subsets of A. Set of all subsets of A. I think let's revise this. Okay, you understand? So when you take a set A, power set of A, it is represented as P of A. It is the set of all subsets of A. Now, if I have this simple set, can you name few subsets? Okay, can I take just one element as a subset? I can take just the second one element. I'll get 2 sets like this, and I can take all the elements. Okay, are we missing any set here? When you take the subsets of a set, am I missing any sets?
5, sir, 5. None.
Very good. 5. The null set is missing. So how many subsets are there? How many subsets are here?
4.
1, 2, 3, 4. There are 4 subsets. Now suppose if A had 3 elements, how many subsets will be there? The set A has 2 elements here. So we have 4 subsets, right? The power set has 4 sets. If set A has 3 elements, how many subsets will be there? Okay, I want you to think about this. I'll pause.
It would be 5.
It will be
5.
5. Oh no, I think I will pause for 2 or 3 minutes. Think about it clearly. Maybe write it down. Okay, so this is what I'm trying to say. If set A has, let's say,
Will it be 8, sir?
very good, 8. So why it has changed?
Sir, as there are 3 elements, for suppose 1, 2, 3, so we are taking as 1 as one set, 2 as a set, and 3 as one set, like that.
Right.
Element. And 1, 2, 3 and 1, 2, 2, 3, like that, sir. And 5
Very
is
good. And then you have the null set also, right?
yeah, that's
But Om, think about this. When your set has 2 elements, 3 elements, maybe you are able to list them down, right? But what if your set has 100 elements? Can you list them down and then count how many subsets are there? But then how do we count the number of elements in the subset then? In such a case, how can we count? Suppose, let's say, this is what I'm trying to say. Okay, your set has, let's say A has, suppose I have n elements, let's say. So I have n elements. Then how do I know how many subsets can I form from this set?
So,
Yeah, sure.
no, it's not working.
So can I do one thing? Can I do counting like this? Okay, so if I look at this way, imagine a different scenario. Suppose I take element 1. Okay, I take element 1. It can be either part of a subset. It can be part of a subset, or maybe it is not a part of a subset, right? There are two ways, right? I can either select one or I don't select. There are two ways. See, if I'm having a subset, see, look at the subsets that you wrote for this. When you took one, in some subsets it is present. In other subsets it is not present. You guys get the idea. So here it is present, here it is present, but here it is not present. You get the point? So I can say that there are two ways in which I can select the first element. I can either select it or I don't select it, right? So for each of these two ways, can I say that there are two ways to select two? Either I select it or don't select it. So when I have the first two elements, there are already how many ways? There are 4 ways, right? In which I can form a subset. You guys are getting? Now each of those 4 ways, when I move to the next element, I can either select it or don't select it. How many ways are there now? 4 into 2, 8 ways. You're getting?
Yeah.
And then you can go on like this. So can I say that the number of subsets, okay, the number of subsets will be, can I say 2 into 2 into 2 into 2, how many times? N times. Can I say this?
Yes, sir. Like, for suppose 100 time till 100, so we have to write 2 raised to the power 100 like that.
Very good. So there will be 2 raised to 100 subsets, right? Now we are using the same logic to understand this number. Okay, so what are we saying? See, if you take relations, what is a relation? Relation is a set. See, your Cartesian product is a set. Your relation is a set. Now your relation is what? Relation is a subset of the Cartesian product. Now when you say number of relations, you are really looking at how many subsets I can make from the Cartesian product, right? And then we have already seen, if you have m elements in set A, n elements in set B, your Cartesian product has how many elements? Your Cartesian product will have how many elements? M into n, right? Now your relation, number of relations is basically you're trying to get number of subsets of the Cartesian product. So if you have n elements, you are saying there are 2 to the power n. I think I should write 2 to the power n here, right? So 2 to the power n subsets. So similarly, if you have m into n elements in your Cartesian product, the number of relations will be 2 to the power m into n. Are we guys okay? So I think I'll pause here for a minute or so, think about it, or I will take questions. Okay, I'll pause. Okay, so let's look at it this way, guys. Suppose, okay, so suppose I have A 1 and then 2, okay, and then B I have A, B, and then C. Now, how many elements are there in your Cartesian product? How many elements are there?
6.
6, right? So what are they? You have 1 paired with A, 1 paired with B, 1 paired with C, and then similarly 2 paired with A, and then 2 paired with B, and then 2 paired with C, right? Now this is your Cartesian product. Okay, this is your Cartesian product. Okay, so we are saying this is your Cartesian product of A and B. But when you say a relation from A to B, okay, so when you take a relation from A to B, now this relation is a subset of Cartesian product. This is important, subset of Cartesian product. Are you getting? So it is a subset of Cartesian product. Subset hai. So matlab you have your elements, right? How many elements are there? The 6 elements, right? The 6 elements. You can take any of the elements, or you choose not to take any element. Get the idea, guys? You can take any of the elements, or you can choose not to take any element. Then you have a relation, and then your relation is also set. See, we are dealing in sets here. Okay, your relation, your Cartesian product is a set. A is a set, B is a set. Your Cartesian product is a set. Your relation is also a set. Okay. Now, suppose if I get few relations, suppose your relation could be as simple as this. Let's say you're only going to get the first 2 elements. Okay, let's say that is the first element, and then the second element. Or your relation, you don't want to take anything, so your relation is 5. Or you want to get last 3 elements, let's say. So 2 comma A, and then 2 comma B, and then 2 comma C, and then so on. So you have these possibilities of sets, right? And all these sets, which are subsets, are relations. See, one extreme is your null set. The other extreme is what? The other extreme is you take the Cartesian product itself. You get? Are you getting? You're taking all the elements in the Cartesian product. So if you want, you could actually define your Cartesian product as the relation itself. Harsha, are you okay? Om?
Yes, sir.
Now, here what are we saying? Now, remember that when we said if set A has 100 elements, the power set of A had how many elements? 2 to the power 100, right?
Yeah.
Now, because I am defining the relation as the subset of the Cartesian product has how many elements? 6 elements. So the number of relations, okay, so can I say the number of relations will be 2 to the power 6. Number of relations basically means you are getting number of subsets, right? 2 to the power 6. Now, where is that 6 coming from? Guys, where is that 6 coming from?
Total elements of
After we multiply both the sets.
Exactly. It's basically the number of ordered pairs in the Cartesian product, right? So this is basically 2 to the power 2 into 3, right? Are you getting?
yes, sir.
Harsha, Om?
Yeah.
Yes, sir.
Yes. So now think about this. So okay, slow down. I know. I mean, maybe after the class you should go through this again because this is very, very important. But think about it. Instead of, let's say, A has just 2 elements. If A has m elements and then B has n elements, then what will happen? Here, don't you think that in the power you will get, instead of 2 you will get m, instead of 3 you will get n, isn't it? So that is what we wrote here. Okay, so that is exactly this slide is. You understand? The number of elements in A is m. There are m elements. So for example, A has these elements. So now I'm not giving numbers, okay, abstractly. Abstractly, we can say we don't know what those A1s are. Okay, so A1, A2, and then so on, A, M. So there are m elements. Okay, similarly, the set B has n elements. Let's say B1, B2, and then so on, Bn. So now if you take the Cartesian product of A and B, the number of elements will be m into n. Now, what are those elements? If you really look at, list them down, they will be pairs, right? Like this, A1, B1, A1, B2, and then so on. Okay, so till let's say AM and then BN. So how many of these? There are m into n ordered pairs. So in the Cartesian product, there are m into n elements. Now, if there are m into n elements, you can choose not to take any of those elements. Then you have a null set, which is a relation. Okay, your relation can be a null set. Or the extreme, you can pick all the ordered pairs. Then your relation is the Cartesian product itself. Or you have a middle thing. Okay, so you can take any number of ordered pairs from the Cartesian product as you wish. So in that case, we can say that the number of relations that you will get is 2 to the power n. Are we okay here? 2 to the power m into n. Fair enough? Okay, Harsha and Om. So you should go through this again after the class. Yeah, this is, in the beginning, I understand. This is not an easy concept to understand, but go through it again, okay? Okay, so now if you have, let's say, a set A 0, 1 and then set B 1, 2, 3. How many relations are there here? Can you answer this? How many relations are there? I'll pause for a while. Okay, Om, I think you're right. So you want to explain your answer?
Yes, sir. As we multiply, we are getting it as a 6, sir.
Okay, so the number of elements in the Cartesian product will be 6. Okay, so, but when you are taking out of this, using these 6 elements, you are forming subsets, right? So that should be 2 to the power 6. Very good. Harsha, you understand?
Yes, sir.
Cartesian product में जो elements है, उसको लेके आप subsets बना रहे हो. Okay, हर एक subset को आप relation बोल सकते हो. You understand? Okay, every subset is called a relation. So very nice. There are 64. Very good. Okay, so now here again some language. Okay, a relation from A to A is also known as a relation on A. So whenever they say relation on A, it means A cross A. Okay, so if they say something like this, relation on A, that actually means A cross A. Just keep this in mind. Okay, so A cross A is relation on A, language. Okay, so now an example. Okay, so if you have a set of the first natural numbers, if you have a relation on A, that means you are trying to get A cross A. How is this relation defined? A is a factor of B. Okay, so they're asking, write down its domain and then range. So I think we'll just list them down. Okay, so you will have let's say if I'm taking A1 as the first element, then I think I will get all these pairs, right? Because 1 divides all of them. Are we okay? So you will get all these ordered pairs. And then if I take first element as 2, I'll get the second element as 2, 4, 6, 8, and 10, right? And then if the first element is 3, I'll get the second element as 3, 6, and 9. First element is 4, I'll get 4 and 8. First element is 5, I'll get this. If I have 6, then from 6, the second element has to be 6. You cannot get any other element, right? So 7, 7, and then 8, 8. You guys understand this? And then in this case, can you guess what is the domain and range here? Om, can you guess what is the domain and range?
Its domain is.
Do you have all elements from A? Did you?
Yes, sir. Yes, sir.
Okay. How about range? Harsha, range? Do you have all elements? I think, right? You have all elements, right? I think in the first list, it's first row itself, all elements are there. So domain and the range are same, A. You're okay, guys? Okay. So I think that's the end of today's session, guys.